Hello everyone, this is part 3 of mass spectroscopy, and we're going to analyze one more mass spectrum to make sure we've all understood. So let's have a look at propanoic acid. Okay, so propanoic acid is a carboxylic acid. So it has a OH group, double bond between carbon and oxygen, and also a OH group. Now let's see how this differs to our previous mass spectrum of propanone, the ketone. If you want to see that, watch the part 2. Now, the mass of propanoic acid is 74, and hence we see a big peak at 74. Okay, so this is due to the molecule with a +1 charge. So C3, H6, O2, brackets, +1. We see a peak at 75 because 1% of all carbons are carbon-13, and therefore we see there will be some of the molecules that weigh 1 more. Okay, now we do see some other peaks. We see a peak at 57, and that's because you may lose an OH group from the molecule. So if we've created a fragment. Okay, now you can use a periodic table to calculate the molar mass of the formulas I'm writing. So this peak is due to C3H5O. So our main molecule has already fragmented in one way. We see another big peak at 45. And this one is a common one because if we scroll back up to our data booklet, this is due to the loss of a COOH group, which means there's a carboxylic acid functional group in our molecule. Now, if we lose this group, we end up, so this peak is due to COOH plus. You can write it in many formats, CO2H if you would like. And another very, very common peak is 29, which if we scroll back up is due to a chain of 2 carbons, so an ethyl chain. Okay, so this peak at 29 is due to, I know I'm changing between formats, but both are acceptable, CH3, CH2 plus. And another prominent peak, the highest, is at 28, and that is also on our data booklet in IB, and this is because of CO bond. So hopefully if you watched parts 1, 2, and 3, we will understand that mass spectrum is used for you to introduce a sample and see what fragments it breaks down into. Now, these fragments will give you a clue as to what functional groups are present and what perhaps alkyl chains are present, like we saw in this peak of 29, that there's an ethyl chain somewhere, or a branch somewhere in the molecule. Now, as I've said in the previous video, we do not use mass spectroscopy alone. We have to use infrared too to give a better image. And obviously, we will also use NMR. So they all work in conjunction. Okay, I would like to acknowledge my sources. ChemGuide, an excellent website for chemistry revision. The mass spectrum, of course, from this database, which I've mentioned before, and the data booklet from IB. Thank you very much. I hope this has helped.